Good afternoon, Chemistry B students. Hope you're doing well. Beautiful day out there. I want to show you a little bit about how ionic bonding works. And so there's a couple things I need you to open. First off, go to your Google Class and open up today's assignment. So let's see where that is in here. Get our Google Class up and running. And we see that we have the bonding review. You're going to need that open. You're also going to need your periodic table open. So open both of those items up. Let me go to that naming ions periodic table just to show you what that looks like. That's one of them. And you're going to want to have this periodic table here to use today. That periodic table is going to show you the common ions. And basically it works. You can also work off a regular periodic table by knowing where the valence electrons are. In the first column, for example, where hydrogen, lithium, sodium, and potassium are, those are all in the first period. And what that means is they are all going to have one valence electron. And they're the alkali metals. You go over to the alkaline earth metals, they're going to have two valence electrons. And notice that they all form +2s. We go clear to the other side. This periodic table does have the noble gases, but again, notice that there's nothing on them. There's no charge whatsoever. And so we have the no charge there, and then we have the negative one here. I'm cutting off, I'm recording something. So it's okay.
I'll come back.
All right. So yeah, Mrs. Brown is in the recording, but so here we go. But anyway, you have these different ions here. You have positive and negative ions. And again, you can use the periodic table. You know that some are going to gain them and some are going to lose them. All right, so let's take a look at how we can use this to figure out like what kind of bond is going to be created with a atom. So let's pull out our notebook, and we have I put down ionic bonding, and I'm just going to do salt as an example, and then I'm going to do magnesium chloride also. First off, salt, Na. We know that it has one valence electron. We're going to use a dot for that, and we know that chlorine, for example, has 7. Okay, so again, it's in the 7th column over there, and I'm going to go 1, 2, 3, 4, 5, 6, and 7, and there you go. This is called the Lewis dot. If you've seen this done before, basically that's what I'm doing. This electron that is located here in the sodium, well, chlorine wants it. Remember, chlorine is highly electronegative, and it's going to pull that electron over to that chlorine. So this electron is going to move over here like so. And what happens? Well, the chlorine now becomes negatively charged. It has an extra electron. The sodium becomes positively charged, and now they can bond together and form sodium chloride. Pretty simple on that one there. But what about when you have like an odd number, or something that's a little bit different? Well, let's take a look at one like that. Magnesium. All right. Check your periodic table, and if we look at that chart that I'm using, magnesium is typically a +2. It's got 2 valence electrons. So we're going to look at that magnesium, and we're going to give it those 2 valence electrons. So I'm going to go 1, 2 like this. Well, what if it wanted to bond with chlorine? So chlorine again, 1, 2, 3, 4, 5, 6, 7. Chlorine can only handle 1. All right, so I go and give it the 1 electron. Well, this chlorine is happy. Magnesium is still not quite happy. It's still got an extra electron. Well, what do I need to do? I need to add another chlorine. So again, I put another chlorine down. Now I can get rid of this other one, okay? And now each one of these is, by the way, a minus charge. So this becomes minus, this becomes minus, this becomes +2. Notice that that's the same as what's on that chart. So you have these things, you have +2, and then you have the chlorine, which is -1. So we got those where they're at. Now I can write my formula. So Mg, I have one of them. I need 2 chlorines. There we go. So I got that all set for magnesium chloride. Now, can get a little trickier if we're using a polyatomic ion, but it's not that difficult. You just got to remember they behave as a unit. So let's pull one off. Well, we have a whole list of them here at the top of this periodic table, and something that's kind of popular is nitrate, which is NO3. Okay, so NO3, and it looks like it's a negative symbol up there, so it's just a simple negative. And what if it wanted to combine with something like calcium and make something like calcium nitrate? Let's take a look at that. I'm going to flip my page and do that one now. So we're wondering about calcium joining up with nitrate. Nitrate is the whole system here has a negative charge. The whole thing does. Calcium typically is a +2. I'm not going to show the electrons on this one because you kind of know now what's going on. If I have this +2 and this is negative, I'm going to need 2 of these to make this work. All right, so now I have 2 negative charges, I have a positive charge, and now we're all happy. And so the formula for this one would be Ca, and then we have to put the NO3 in parentheses like that, and then we have 2 of them. Okay, so that's how you work with those polyatomics. So now let's take a look at our actual document for today and take a look at that. So we have the copy of bonding here. And now we should be able to do these. I'm going to do each one an example of these to help you out. Let's start with this first one. It already gives you 2 ammonium ions. Ammonium, again, is on that chart. It is located over on the positive polyatomics. It's over in the far right column there on that top where it says table of polyatomic ions. Positive polyatomic ions, you have ammonium, which is NH4. So that's right there, pretty easy to see. That's one of the only positive ones. Well, if I have 2 of those and I have 1 SO4 ion, I can go ahead and make that molecule. I'm actually going to copy this right here. So I'm going to copy this, put this down over here in my answer part. Okay. And now I can take the SO, but I'm going to have to put parentheses around this. So I put a parentheses here, and I'm going to go Control, take away the subscript feature there. And now I need, it looks like I need 2 of those because that's what it's telling me in that thing. So there, and I go with 2, and then I undo that. And now how many? I only need 1 of the SO4, so I can copy that and place that over there. So I'm going to copy that and place that right there. So there, that one is done. I got 2 ammonium ions and 1 SO4 ion. It's balanced out. The 2 positives and the 2 negatives, that's going to be just fine there. So that ion or that molecule is done. And that's ammonium sulfate, I believe the name of that. We'll get into more of that naming on Monday. Okay, now we're going to reverse the direction. We're going to try to, now you have to sort of figure out how many of each of these you're going to use in this next one. So the next one here, NH4 is positive. Phosphate over here is 3 negative. What do I need? I'm going to need 3 of these. Okay, so I'm going to need 3 of these to balance, and I'm only going to need 1 of these to balance that out. So now I can, again, I'm going to copy that ammonium, Control C, come over here, Control V, and I can put parentheses around it. There we go, and I need 3 of those. So I put a subscript of 3 on that. And now I can then bring the phosphate over. That does not need parentheses because that one is totally on its own. I mean, it's just one single unit of that. It has a -3 charge. I don't need parentheses on that. So that's how you do the second section. Now, the third and final section of this is you're going to write the compound based on the chart here. So I can pick any one on here. I'm going to pick one in the middle. Let's do the aluminum and sulfur. So I'm going to do this aluminum here, and I'm going to do this sulfur here. So they actually meet together right in the middle. Aluminum is a +3. Sulfur is a -2. What's the only common factor for those particular atoms? So think about that. I'm going to copy my sulfur here. So 3 times 2 is 6. That's a +6. So I'm going to need a 2 on that aluminum. So I put a 2 there. On the sulfur, what times 2 is 6? Well, that's a 3. So I'm going to put a 3 on the sulfur, and that one is done then. So that balances out. You can double check the math in your chill if you need to. to complete that. And that's how you go about doing that chart there. Make sure everything is in blue. I'm going to go back and highlight these answers in blue as well. And if you have any questions on any of these and how to complete ionic bonding and how to do it, just send me an email. I will be on email tonight. So if you get this done, this assignment is due on Monday. And again, make sure you possibly build a learning tracker for the yellow line and see how this might relate to the yellow line. It'd be kind of cool to see if you guys can think of anything that this is related to. And have a great day. Go Bulldogs.